Hey folks, Mr. Hartzler here, and I'm going to talk to you in this video about solving inequalities and equations by graphing. Sorry, I just had to check my notes again. So I'm going to share my screen with you and we'll go through some examples. Here we go. All right, so we're going to solve equations and inequalities by graphing, and let's get started. So the target for this is that I can use graphs and tables to approximate solutions to algebraic example or equations and inequalities. We're actually not going to use tables. We're just going to look at graphs because honestly, instead of tables, use a calculator or a spreadsheet, right? All right, so let's go. We are going to be solving this equation by graphing. So first step, which I listed them over here, is to set each side equal to y. So let me pick a different color here. Let's do purple. Left side, 3x plus 20, it's a negative 3x plus 20, is going to be equal to y. Awesome. And then we're going to do that same thing with the other one. Let's have it be green. And the other side is 5. We're going to set that equal to y. So I'm going to do each of these and I'm going to graph both of them. So let's actually do the y equals 5 part first because that sounds super easy. And, but this 20 is going to make things difficult. So I'm going to count by 5s. All right, so all of these are going to be 5s. This is up 5s. This is a 10. This is 15, and it's going to go the same way along my x-axis: 5, 10, 15. So if you're one of my students, if you're graphing stuff, you have to label your x and y axis. It doesn't work if you don't do that. So how else do I know what your scale is? That's an important thing to know. So there's that. Now we got a graph. So right here, 5 equals y. Y is 5 right here. And I'm going to draw that line. There it is. And the other side too. There it is. Now I'm going to graph the purple. So this is set up already like the mx plus b format we're all used to. Slope, intercept, slope, and then your intercept. So I cross at 20. That's up here. So I'm going to put a big, nice, solid dot at the 20. And then I do my slope, down 3 over 1. Down 3, that's probably here, over 1. Down 3 over 1. I'm actually going to use the line tool on this one because this sucker is going to be tricky. All right, and there's arrows on both ends, but I'm not going to draw those right now because that takes time. So this will help provide us with our answer, and you'll see too, we probably crossed right about here. That looks like 5 would be our answer. So let's double check this using some algebra, right? So I'm going to subtract my 20. This is how you probably used to do this, right? Negative 3x equals negative 15. I'm going to divide both sides by that negative 3. X equals 5. That's the algebra way. And we got 5 doing the graphing way. So wherever I have an intersection of lines, that is the solution to my equation. All right, let's go on to the next one, folks. All right, so we're on to the next one. And this one has an absolute value. Don't let that part scare you. Really not that bad, right? We know in general, absolute values, I'm just going to write ABS, looks like a V, either pointed up or pointed down. But because there's a positive outside, we know it's going to be pointed up. And now all I have to do is do this shift. So because I'm inside the absolute value, that shifts me left and right. And it's a negative 4. So I do the opposite of that. I go positive direction. My desk lamp turned off on me. So I go to the positive direction. So I'm shifting to the right. So I'm over here. 1, 2, 3, 4. I need to write in my scale so everybody knows what it is. All right. So I have both my x and y axis labeled. That's important. Now I can graph this. So I'm shifted to the right 4. I'm looking at the number in front of the x and the number outside. There's nothing there. So I know it's a 1. So I have nice, pretty lines. I'm just going to do straight lines here, actually. And it's going to look like that and like that. Now I have to graph the other side, right? Because we're setting y equal to each side here. So this right side, let's do green. Why not? 1/2 x plus 1 equals y. Again, we're in slope intercept. Y equals mx plus b. B being my y-intercept, so I cross my y-axis at 1. And then from there, I go rise over run. I'll write that down. Rise over run is how I determine slope. So I go up 1 to the right 2. So I go up 1 to the right 2. And I'm going to use a nice straight line again to do this one because that just makes life easier. Right there and right there. Cool. So I actually have two solutions on this one. I have one. Ooh, I'm still doing the curvy lines. I have one that I can see right here, and I've got another one over here. My graph is just a little bit off. That's my problem. Yep, my bad. Let me erase this real quick. Let's fix this. That's why I do notes on this too, folks. All right, so I need a straight line from here, and it comes up this direction. There we go. So now you can see my solution is right here at 2. My x-axis is going to tell me my solution is. So my answer is going to be x equals 2, and that was given to me from my graph. Where my two lines intersect, that's my answer. And again, we do have another one. It's over here, but I didn't draw my graph shifted to the left far enough. You guys will have to. Anyway, all right. So let's go on to the next one. So on this one, we have a little bit of a different situation, right? We've got an absolute or an inequality here. So we have to graph this whole piece, and we're going to look at where is this piece true. So we have x squared, so I know it's a parabola. So I'm going to graph this. There's no shifts in it, so that's kind of nice. So I know I'm starting at the origin, and from there I've got a beautiful little curve going up, beautiful curve going up. I need to draw on my scale. 2, 3, 1, 2, 3. Once as simple as this, I'm okay with you not finding more points and making sure your parabola has the right curviness to it or eccentricity. We're just going to kind of leave it as it is for right now. It doesn't really matter. So where is my graph strictly greater than 0? Well, now this is a y. We can treat this like a y value right now. So where is that greater than 0? Well, at this bottom point, at that dot, that is 0. So that would be the equal to part. So it's not that. So it is all of this chunk here, all of this, and then it's all of this chunk on the other side as well. So it's kind of messy now. I'm going to get rid of a couple of those lines. But you kind of see the section that we are looking at. Okay, so I'm going to list this a couple of ways. One of them is going to say x has to be less than 0, because that provides me with this left blue line, blue curve, or x can be greater than 0. If I plug in a 0, though, 0 squared is equal to 0, so it's not greater than 0. It has to be greater than, not equal to. So there's another way of writing this, and I could say that I could go from negative infinity to 0, parenthesis, that means I'm not including it. If I would use a solid bracket like that, it means I am including it. And remember, not equal to, so not this one. And I read or 0 to positive infinity, and I'm using parentheses on both sides because I can't actually be at those locations. All right, so now we're in here, and I'm actually looking at Desmos. So I'm graphed both of these lines. You can see them over here. So the question would be written like, find the solution by graphing for this problem. Both those graphs but set equal to each other. My solution is right here in Desmos. So it's right here where these two graphs are going to cross each other. The nice thing about Desmos, right, is I can click on it. So if I click on that spot, it tells me my answer. Now the question is it the x coordinate or is it the y coordinate? Oh, they go away when I click on them. Dang. So when I click on it, it's important to remember that it's going to be my x component of this. So it's wherever I cross on my x, that's going to be my answer. So it's, in this case, 0.697. And then up here, it is 4.303. Both of those are my solution. So I hope this video was helpful. If it was, hit that like button down below. Comment if you have questions. If you're one of my students, please send me an email and I can get to those as soon as I can. I hope all of you have a phenomenal rest of your day. Bye, everybody.